So today we are going to talk about how to solve first order linear differential equation. First order linear differential equation. Let me introduce you the format of a first order linear differential equation. First of all, when we talk about first order, it means the highest order that we find is 1. So that means in our differential equation, maximum order we found is f dash x. Okay. So first order linear differential equation means that is, we can write the format like f dash x plus, or if fx is equal to y, let me take y dash plus px y is equal to q times x. Okay, to make sense, general linear differential equation means it is in the format like this. Let's say f double dash y double dash plus y dash plus y is equal qx, something like this. You see, this is the format of a linear uh, format. Since we talk about the first order linear differential equation, uh, only y dash is the maximum order we can find. So this is the format today we are going to talk about, and we're going to talk about how to solve this kind of differential equation. So to differential equation to be linear, mainly you have to remember three things. In the format of linear, there should not be any powers of the derivative like this one. So that means here, but we talk about the degree. Okay, in this example, order is 2. I'm not considering first order linear differential equation. For any kind of a linear differential equation to be linear, the order should be 1. Order should be 1. And order means the highest power is the highest order. Okay, here highest order is 2 by double dash. Its power is 1. So order is 1. So order should be 1. And there is no products between y and its derivative. No. Okay, it should not be. Okay, should not be powers of the derivative or y. So we can consider simply this y as the zero derivative. Okay, and no multiplication between two y terms. This is y. Here what I mean, y is dependent variable. In ODE we have only one independent variable, like most of the time it is x, and one dependent variable y. So no multiplication between the dependent variable y, and no functions of y, like there is sine y, like ey. There should not be something like that. So it should be clearly as y to be linear. So when it comes to first order, the linear format can write as this. If there is some x term behind this y dash, you can simply divide it from all the equation and get to this exact form. Okay, from nowwards, this is the exact form we are going to talk about. Okay, if you could, you should remember very exactly to solve equation, this is must. Okay, if there is some kind of px inside y dash, like you say qx, y is equal, okay, capital qx, you have to divide the whole question by px. Okay, so because we are deriving the our solution like that way. So imagining our equation is this. Now let's solve the equation. Okay, what we have is y dash plus px y is equal to q times x. Also, there is another point here. If this qx is equal to 0, we call it homogeneous. And if this qx is not equal to 0, we said it is non-homogeneous. Okay, it is just some notation. Do not hesitate with the homogeneous we talked in previous video. That homogeneous is not the same meaning as this. This is linear homogeneous. Okay, this is linear homogeneous. Okay, let's get started. First, to solve this differential equation, what we're doing is we divide uh, the differential equation must be exactly this form, and we are multiplying the whole equation from qx. Let me say qx is another function of x. Okay, qx y dash plus px qx y is equal qx times simple qx. Now okay. Now here is the miracle happens. We choose qx such that y times qx altogether derivative is exactly as these two terms. We choose qx in such a way. Okay, so now this is equal to qx times qx. So if we choose qx in such a way, what is qx be? So if we differentiate this term, we get y dash qx. So we get exactly this. So it's fine. So next term is y times q dash x. So q dash x should be equal to this term here to be this whole derivative exactly equal to these two terms here. So q dash x should be equal to px times qx. So now let's find out what is qx means. So q dash x over qx is equal to px. So what is q dash x means? Q dash x means like uh, dq over px is equal to px. So this is also a differential equation, and this is variable separable method. So dq is equal to, oops, there is a q down there. Q dash x means dq over dx over, that is qx here. Okay, so this is a differential equation, and we can solve this using a variable separable method. So I uh, oops, sorry guys, I messed up all the things. So this is wrong. Okay, this is not the way, because there is no several variables. There's only x here. So what we have to do is we should integrate the both of the sides from x. This should be equal to integration of px dx. So if this is equal, the integration from the same uh, variable should be also equal. So here, what is the integration of q dash x over qx? In earlier videos I told you, if the differentiation of the denominator is on the numerator, we can write it directly as ln qx. is equal to the integration of px dx. So then qx would be e to the power integration of dx dx. If you have seen this in the first time, it could be some kind of little bit surprising, but when you're solving differential equation, you can get some kind of some root functions. So this is the function, okay? This is a function of x. So this is what we got q. So if you remember, so if we choose qx in this way, this derivative here equal to the both of them. So now let's continue solving our equation. It's y times qx dash is equal to qx times qx. So now what we have to do. If these two terms are equal, we just have to integrate the both of the sides from the same derivative. Dash dx is equal to integration of qx qx dx. So since uh, this is integration, we can see it as the antiderivative. So since this is a derivative, we can simply write this as q times y times qx, because there is a it is a derivative. It is equal to integration of qx dx. So we will solve the equation. So you would wonder that there is an integration. It's no problem, okay guys. So solving a differential equation means there is no derivative. So it could be integration is fine. There is no derivative. So we solve the equation, and to solve that we need this qx over here. We call this qx as integration factor. Since we multiply the whole equation by this qx, we tell it that name. So this is the integration factor. We also say that this is integration factor method. So integration factor method is used to solve the first order linear differential equations. So here are the steps we should follow to solve first order linear differential equation. First, you have to either what you can do is you can directly understand that this is a linear differential equation, and most importantly you should get into this format. This is the number one and important thing, format. Okay. I tell again, if there is x terms inside the y dash term, you should divide the whole equation by that x terms and get exactly this format. Exactly this format, that is number one. And you multiply the whole equation by the integrating factor. Then you should find the integrating factor. In a real life solution, you should find the integration factor, and then you solve the equation. Means you integrate both sides on the same variable. So we solve it. So let's jump to the question. So this is the first question. Dy over ds is equal to x plus y sin x over 1 plus cos x. So first thing we have to do is we should make it to the format we earlier derived, because that is how we solve. So y dash is equal to, we can break this to two terms, x over 1 plus cos x plus y sin x over 1 plus cos x. So this is equal to y dash minus sin x over, if it say plus minus sin x over 1 plus cos x, it is the same as that, times y is equal to x over 1 plus cos x. So now we have the exact format of our that we derive our equation. So next thing we have to do is we have to multiply the whole equation from qx. That means the integration factor. Integration factor is qx, so qx times y dash plus minus sin x over 1 plus cosine x y. Before that it should be qx y is equal to x over 1 plus cos x times qx. So what is qx? Now we want to find what is qx. I think in problem solving you have to remember what is qx is. Qx is, if you remember, qx is from here. If you have some kind of a hesitation why I didn't put an constant, because when we are doing integration there is a constant always. We don't normally put it here because there are more integrations coming here in the problem. Okay, so if you put another const here and another new const here, you will have to face a lot of problems. So what we doing is, if it is not necessary, we don't put an constant into this integration here, except we at the final step we put all the constant to a one constant. Okay, so our integration factor is e to the power integration of px. What is px is integration of px dx. Now what is px is, if you look at the equation, px is this term over here. So px is equal minus sine x over 1 plus cosine x. So we have to integrate the px dx. So it is integration of minus sine x over 1 plus cos x dx. So again, the differentiation of the denominator is on the numerator. So what is the differentiation of the 1 over cos x? It is just minus sine x. So this is ln 1 plus cosine x. Again, there's the constant. I didn't put up in here. What I did is I put it at the end of the uh, all integrations. That is not necessary. So I will put back to here. So qx means e to the power ln 1 plus cos x. Again, in earlier videos derived that e to the power ln x means it is just x. So this is just 1 plus cos x. So again, if you don't know how to do it, it is kind of this way. If we imagine that k is equal to the e to the power ln some kind of a function there, let's say x for is, or anything it could be. We take the both of sides ln, it could be ln e to the power ln x. So while choosing the properties of the logarithm, this ln can be brought to here. So ln x times ln e. So ln is equal to 1. So ln k is equal to ln x. That implies k is equal to x. So no matter what is the function inside this term over here, it is the uh, answer of this whole thing. So we can just put qx is 1 plus cosine x. So let's solve the equation. Now our equation is, if you remember, we choose qx such that this y plus qx dash is equal to this whole term here. So it is just equal to x over 1 plus cos x times qx. So now we have to do is, we have to integrate the both of sides from the same variable dx. So y times qx means 1 plus cos x, is equal to integration of x over 1 plus cos x times qx means 1 plus cos x dx. So these two terms are cancelling out. It is really easy. Integration of x is equal to x over 2, x squared over 2. So our final equation is y is equal to x squared over 2 times 1 plus cos x plus c. So this is the solution for our differential equation. So don't remember to put the constant here, okay? Okay, now you can understand why we don't put a constant here, because if you put an, if after this integration and this integration there are const, we can say altogether there is c dash constant here. So when you get q dash, this there should be some plus c dash here. By using the rules of power, it is just like k times e to the power integration of px qx. So what is just happening is it is just a constant came here. So if you see that even there is a constant here as k times k times. Okay. In the integration you can get out the constant. So no harm to our answer. So we can put the const at the last. So next to the next question. So this is the next question. Square root of x times y dash is equal to e to the power 2 square root of x plus y. So first what we have to do is we get the our standard first order linear format. So it is like y dash minus 1 over square root of x times y is equal to e to the power 2 square root of x over square root of x. So there should be no uh, constant or any terms in front of y dash. So we divide the whole equation by square root of x. So this is what you get. So I will done it quickly. So what we have to do is we have to find the integration factor. Integration factor is qx. Qx is just equal to the integration of e to the power integration of px qx dx dx. So next so px is equal to, if you look at the question, it is like minus 1 over square root of x. Don't remember the minus sign. It will probably make you a question, because this in the standard form there is a plus here. So if you add plus here, there should be minus over here. So px is probably minus 1 over qx. If you integrate it, if you integrate px from x, what you get? Minus sign is a const, so it is x to the power minus 1 half dx. So you can just use the uh, power rule to integrate this. So it is minus x 1 half over 1 half, that means minus 2x square. So that is the px. So we choose integrating factor such way that these two terms is equal to this, is equal to e to the power 2x over square root of x times qx. Now what is qx? Qx means now before that we have to integrate this. Integrate this from x, integrate the whole term from x. So we left off with qxy, that is equal to integration of e to the power 2 times square root of x over square root of x times. What is qx? Qx means e to the power integration of px dx. Integration of px dx is equal to minus 2 times square root of x dx. Now, if we simplify these two terms, what you get? It is like e to the power 0, that is equal to 1. Because when you have a multiplication with the same base, so just you can add this square root of 2x minus 2x. So you take up with 0, so e to the power 0 is equal to 1. So qx times y is equal to integration of this is 1 over square root of x dx. It is just we done few minutes earlier. Square root of 1 over square root of x. It is just 2 times square root of x plus c. So finally, our solution is qx is, oops, sorry, there is some kind of window pop-up. I don't know what is happening. If that's happened because when there is fully charged my device, it is automatically leave me a pop-up message and opening the Chrome. So qx is e to the power minus 2x to square root x, y is equal to 2 square root of x plus c. So this is the solution. So guys, it is very easy, and if you follow the exact rules, it is really easy, and you can do the question really quickly. So first you have to bring it to the format. Second, you have to find the integrating factor, and then you plug into the integrating factor, and next you have to solve the differential equation. So is that the steps I gave you? Yes. Format, and then the integrating factor, and find it and solve it. Okay. So let's move to the next question. So I let you to do the next question. I choose the next one uh, to you, and I choose the final one. X log x times y dash plus y is equal to 2 log x. So I should get it to the standard format. So it is y dash plus 1 over x log x times y is equal to 2 over x, because log x is cancelling out, so it is 2 over x. So next, what we have to do, we have to find the integrating factor. It is just equal to e to the power integration of px dx. So px is equal to 1 over x log x. So integration of px dx is equal to integration of 1 over x log x dx. So if you have confusion, they are given as so if they are given as log here. But in calculus, if they are not explicitly say that this is another base, you can always, I don't say always, but we normally means the creator of the problem is always expecting this is e to the power. Okay, this is just as ln x. They're given as ln, because ln x is equal to log e to the power x. Uh, uh, so if they are not telling explicitly, always they mean by log x means the same as log, when in this format there is no base. So which base? So normally it is e to the power e to log log base ex. Okay. So if so, you can see that integration of the denominator. What is integration of the denominator? If we take denominator as like this, you can rewrite this as 1 over x over ln x. No, it is the same as this. So integration of the differentiation of the ln x is on the numerator. So we can write like ln x. Oh, in here they are given like log x, ln log x. So we're fine. So integration factor is e to the power ln log x. So I tell you, e to the power ln something means the answer is this uh, function right there. So qx, we find it. Now it's fine. Now just we find qx in such a way that these two terms is equal to qx times v altogether derivative. is equal to 2 x times qx. We have just we have to just integrate both of the sides from the same variable, and we left up with qx. Y is equal to 2. The const qx means log x over x dx. So how to solve this? This is also a really easy integration. We can see like this as log x times 1 over x dx. So uh, if you learn integration, you will probably know that if there is a function and there is its derivative, it multiplies with the derivative, and we have to integrate it, and there is, let's say, fn or any kind of thing, or n can be in 0. So if there is a function and its derivative multiplied, so this is equal to fx squared over 2. It is just like we are integrating x to the power n. It is equal to xn plus 1 over n plus 1. This happened because this x is, if you differentiate this x, it is 1. So 1 is here. We don't see it. The same rule applies to here. Even there is a function fx, if it is multiplied with its derivative, we can just integrate this fx as like we did here. It's just kind of power. So if we apply that rule to this problem, we have log x and its derivative or its differentiation multiplying it. So we just have to do here log x squared over 2. So these two terms are cancelling out. There is a constant here. So the answer is qx is just log x times y is equal to log x squared plus 6. So this is the answer. So you see that to solve differential equation, you should have a very good understanding about integration and some tricky methods in integration that we have done. If you think that why this happens, you should think about it. Why it happens. It will be easy if you think the other way around. Okay, if you think integration as an antiderivative, if you derivate this, the answer would be this. So if you derivate this, you will get the answer like this. So let's move to some practical questions from this. So let's read the question. A particle of mass m moves in a straight line under the influence of a constant external force, while experiencing an air resistance proportional to its velocity. So the problem is says there is a particle and it is moving in a constant external force while experience a resistance proportional to its velocity. Let's say this is moved to this side, right side. So there is another drag force here. Let's say F drag also. So while experience air resistance proportional to its velocity. Initially, the particle is start from rest, so it is given an initial condition to find the equation. So what is the asked is form a differential equation for velocity. So if we use Newton's law, if this particle moves towards here, if we use sigma f is equal to ma, so f minus f drag is equal to m times acceleration, means you can write like dv over dt. So f is equal to, they given like the drag is equal to, drag is proportional, this drag is proportional to the, maybe we can write this also as dv over dt. This drag is proportional to the initial velocity v. So drag is, we can say it is equal to k times v. So f is equal to k times v plus m dv over dt. So this is the differential equation for velocity. So next they ask, solve using integration factor. So before solve this equation using integration factor, we have to get this to a standard form. So what is the standard form? dv over dt, I would write it as v dash plus k over m v, k over mv is equal to f over m. I divide all the equation from m. So we don't have to hesitate because this k and m are constant, and this f is also constant because it say that a constant under constant force. So we should first find qx, our integration factor. It is equal to e to the power integration of px dx. If we find what is px here, it is a constant. It is just k over m. So if we integrate, uh, let's say this is t, because now we are talking about our variable is time. Okay, so it's dt dt. So pt is k over m. So integration of pt dt is just integration of k over m dt. So k over m is a constant. If we integrate 1, it's t. So we choose integrating factor such a way that this whole term is equal to this term here, and it is equal to f over m. This is also a constant time qt. So you integrate both of the sides. If you integrate both of sides, you will get qt times v is equal to integration of, I will write f over m, which is a constant, times qt. So plus c. So what is qt? Qt is e to the power k over m t times v is equal to f over m. Integration of qt is e to the power k over m t. So dt. So if you integrate this, you will get f over m e to the power k over m t over k over m. So m is cancelling out. What we left up with is e to the power k over m t is times v is equal to f over k times e to the power k over m t plus c. You can further simplify this if you divide the whole equation from this term here. V is equal to f over k plus c times e to the power minus km over t. So this is the final answer. Since it given as v0 is 0, because when the time is 0, it says it is stay still. So if we apply that initial condition, we can find k. What is k then? No, we can find if t is equal to 0, this term here becomes 1. So c becomes c times 1 plus f over k become 0. So c is equal minus f over k. So our final solution is v is equal to f over k. Since this is minus f over k, we can get f over k as a common 1 minus e to the power minus km times t. So this is the final solution. This is the governing solution of this motion. So let's move to the next question. It is something extended of the question we talked about earlier. Cooling with external heating. It says the body is cooling an environment of 25 Celsius, but at the same time it is being heated by an external source that supplies the heat at a constant rate. So again, there is something we say some kind of this kind of object here, and it is cooling in an environment. So this heat is dissipating in an environment, and it's given that the rate of change of temperature is proportional to the difference between uh, so the dissipating rate is like we can say dt over, so the rate of change of temperature is given as proportional to uh, the temperature difference between the object. Let's say at initial time it is t minus 25. Okay, this is proportional to it. But the question gives us the extra thing that this is also heating at the same time in a constant rate, const, constant heating. So we know that uh, in a single equation you know that q is equal mc theta, mc t, you know into a simple kind of equation that is. So in that we can get that the q is proportional to t. So if it is that you heating means it is they are talking about the joule, okay, heating. The heat and the temperature is kind of two words. So heating is what the energy, the temperature is some kind of a function. When you heating up, temperature goes up. So kind of thing. So heating and temperature is kind of two things. So when there is a constantly heating, so temperature is also rise constantly. So in this scenario, now the dt or dt is proportional to this is what? This is cooling plus, now this is also uh, constantly rising. We can say like h. This is just some kind of a constant. So if there is no const like this way, if you remember in the first page you talk about this is a variable separable method because there is a const. Now here we have to use this method. Uh, so now I get the equation. Sorry, dt over dt is equal to k times t minus 25 plus h. This is a const, okay? So even though I multiply it by some const, it is remain as a const. So yeah, so this is the equation. Now we have to get this to a standard formula, t dash minus k. Now if you think that if you want this k to be positive, you should add minus sign here because uh, this term over here is a decreasing term. Okay, so it is cooling, so it will be minus sign if you want this k as positive. So I will choose k as positive, so there should be minus sign here. So plus kt is equal to 25k plus h. So this is the differential equation. So now we have to find qt. Qt is equal to e to the power integration of pt dt. So what is pt? So what is pt? Pt is just a constant. So integration of pt dt is equal to integration of k times dt. It is like just kt. So qt is equal to e to the power kt. Now we are fine. Now we have just solved it. So we find qt in such a way that this whole term is equal to this and 25k plus h times qt. Now if you integrate both of the sides, qt t dash dt is equal to integration of 25k plus h times qt means e to the power k t e t. So this is just qt times t equal to these all are constant. Okay? These all are constant. So you just have to integrate this one. I will write directly 25k plus h times if we integrate e to the power kt it is just e to the power kt over k plus c. Hey, we solve it. We solve it. Now we have to apply the initial conditions. So initially say that when t is equal to 0 it is temperature is 80. So here the qt is e to the power kt. So when t is equal to 0 this term is equal to 1. Okay, t is equal to 0 this term is equal to 1 and here this is also equal to 1. So t is equal to 80. So 80 is equal to 25 plus h over k plus c. So c is equal to 55 minus h over k. Yes, this is all further we can go. So final answer would be if I divide the whole equation by e to the power kt, t is equal to 25 plus h over k. So if I divided whole term by this to this will cancel out, and if I divided k from these two terms it is just 25 h over k plus c means what? C means 55 minus h over k times e to the power minus kt. So this is the final governing solution. So it is very easy and you see there are many applications of this. So this becomes a linear equation because of this constant heating. Uh, I guess you understand the physics behind this. When there's a constant heating, temperature is also rising constantly. So this is a plus constant here. This is the cooling rate. So this is the presenting rate. So it is will be minus if I place k as positive. So this is the common equation. So if we solve it, we get this. So there is another question you to try out a circuit question. Maybe I do it. So what this question says is uh, so the question says there is a circuit. In the circuit there is a voltage source and there is also a resistor and there is also an inductor and with the same inductance is L. So if you use KVL, so if you have KVL, we get V. So there is a voltage drop across a resistor. This is a pure resistor, so it is like uh, I times R. Let's say I, because it should be to work on this circuit. It should be an alternative current. That means if there's a constant current, maybe I should not draw like this. I should draw like this. This is a voltage source. So V minus IR, and since there is inductance, we know when there is a current passing through an inductor, there is an voltage generating. So this is like working as an voltage source. It is actually not a voltage source. The voltage is generating to the opposite side. That means if current is coming from this side, the voltage is inducting towards the other way around. So since it is voltage is conducting other way around, we should know it. It is minus sign. It is according to the Faraday's law. Faraday's law. We know that inducting voltage, be it say EV or inducting voltage or VE, inducting voltage is equal to L times di over dt. So it is L times di over dt is equal to 0. So here we have our differential equation. This is the first order differential equation. We have to solve this. Question given the values for this, so we are not considering about the values, but we are focusing on is solving this. So if you don't understand this concept, uh, go ahead and learn and this inducting voltage. So I just go to the standard form. So it is, I say I dash. I have to divide all the equation by L. I dash plus R over L I is equal to G over L. So I just plug in the value. So R is given as 5 and L is given as 2 and V is given as 10. So I dash plus R over L means it's 5 over 2. 5 over 2. I is equal to V over L means 5. So this is the equation we have solved. Now we have to find the integration. Now this is the first order linear equation. So we know the method from our head. So what is we are going to do? We are going to find the QT. So the QT is equal to the e to the power integration of PT dt. So PT is just a const 5 over 2. So QT you can directly write as e to the power integration of PT is 5 over 2 t. 5 over 2 t. So we find QT such a way that this whole term differentiation is equal to this and 5 times QT. You need to practice the method to write these steps directly. Since we have proven it earlier, I just now doing it quickly to practice you to in the fast way. So if I integrate the both of sides, I dash dt is equal to integration of 5 qt dt. Okay. Don't worry, they are not bombs. Okay, there is some bombs also all the way around with this. It is just a festival that's going on there, and they are just firecrackers. So it is qt means e to the power 5 over 2 t. I is equal to 5 integration of e to the power 5 over 2 t dt. This is just equal to e to the power 5 over 2 t over 5 over 2. It's cancelling out. The final solution is e to the 5 over 2 t times I is equal 2 times e to the 5 over t plus the constant. So I divide the whole question by this term, so I get I is equal to plus c with the minus 5 over 2t. So this is the governing solution. So initial condition is given when t is equal to 0, the current is equal to 0. So if we have the initial condition plus c, so that implies c is equal to minus 2. So the final answer is I t is equal to 2. Since c is also minus 2, I can get common as 2, so minus 1 minus will become minus 5 over 2. So if we are moving further and if you are looking forward to electrical engineering, this is some kind of application that you will find. So there is some kind of, we say, some steady state. It is I is equal to 2 ampere, but steady state means when t is equal to so that means is when the time is infinite. When the time is infinite, time is no, time is goes to infinity. I just signed some more than solving the differential equation. When t is go to 0, you would find that this term on here it is minus infinity. So e to the power minus infinity is 0, because if you see the graph, when it is minus value, it is approaching to 0. So in steady state, it is 0. So there is another method of solving these equations. There is a complementary solution and a particular solution. We would talk in those in future videos. And in electrical engineering, to find that this kind of thing happen, uh, there is something called transient analysis. Transient means when there is a change. Okay? So rather than, this is a really easy set. This is a really easy circuit, because if there is more complex circuits, you cannot solve this differential equation really easily. So there is a method called Laplace transformation. So by using Laplace transformations, you can do very quickly these things uh, than this. So we will do those also in future videos. So thanks for watching. We will meet in another method of solving differential equations.